we want to change the world through material science. Specifically, what we're trying to do is we're trying to change the world by providing clean water. And, it's hard to imagine a more strategic or a more valuable resource in the world today, and something that's also as simple. It's everywhere, but it really is a challenge for people, even in the developed countries, to have clean water. And what we're plagued with here in the U.S. and other parts of the world are these PFAS contaminations. And these are chemicals that are necessary. They do a lot of good, but unfortunately, they do have some toxic side effects. And they really earn that name forever chemical because they just don't break down in nature. So we have to find a way to destroy them. Current methods of removing PFAS from water, they do just that. They remove them from water, but now you still have a contamination that you have to do something with. Oftentimes it's buried, which can leak, or it's incinerated, which can have bigger problems. So what we've been able to do is, using materials technology combined with existing water treatment technology, and we have found a way to design a system that not only removes PFAS, but exactly the same time it destroys it. And it destroys these chemicals by breaking the bonds. And that carbon fluorine bond with what makes up PFAS it's among the strongest bonds out there. And having the ability to locally break those bonds and destroy these chemicals, it really is a differentiator in what we're doing. And we're able to do it in a way that doesn't require a lot of energy, doesn't have a lot of cost. And it's a remarkably efficient and small footprint type of technology. So we're pretty excited. It changes that cost benefit analysis. It changes the amount of capital, the amount of OpEx you need to get rid of PFAS. So we're really excited. We're well beyond the lab. We know the science works, and we are actively preparing for our first pilot, which we expect to be here in the state of North Carolina. And then we're engaged in a number of conversations with a lot of other folks, from small industry to larger industry to other, governments and municipalities. I am, by education, I'm a material scientist, and I'm also a chemist. I have been a, process engineer, I would say, for the first part of my career. And all that really means is we were in the business of making things. We weren't in the business of inventing, or we weren't in the business of just working in a laboratory. Our goal was to commercialize cutting edge technologies. And I've been very fortunate. I've had some really cool jobs. My first job out of college, I was making solar cells for satellites. So I have devices that are, still closer to the edge of the solar system, even on the surface of Mars. Worked for another company where we were working on revolutionary LEDs, different colors and different interesting things. Got bored with 2 dimensions, and for glutton for punishment, I went into 3 dimensions and started working on micro and nano machines. I was part of the teams that were some of the folks that made really the beginning of the Internet of Things. The sensors that are ubiquitous today, that are in your cell phones, your game controllers, in your cars, were part of the teams that really, commercialized that technology. And then along the way, Jason Taylor, co-founder, and I, we worked together at a previous job, and we had always kicked around the ideas of starting businesses together. And Jason is also a material scientist, also process engineer, and we came up with some ideas, and then we grew the team. Mark Edmond is another key contributor to what we do. We've worked together. All of us started working together in the late '90s, so it's a core of people that we really know each other. We really trust each other, and we've always made things. And I think that fits perfectly for what we're trying to do now. We have this unique technology that we're really the only ones in the world that have access to. And we've been able to figure out how to commercialize it, and how can we commercialize it in such a way that we can grow a company very, very quickly. PFAS there are chemicals that have been around on a commercial scale, I would say, really since probably the 1940s. And these are chemicals that do have quite a bit of value. They do a lot of interesting things. If you have something textile that is waterproof, or if you have a fire extinguisher that's foam based to put out fires, and if you have things that are non-stick, contact lenses, there are food packaging so that your food doesn't stick. There's a lot of different materials that have these compounds. There's thousands of them out there. The problem is they are extremely stable. Like I said, that carbon fluorine bond is extremely strong, so it just doesn't break down. It doesn't break down over time. So what happens is, as these things are thrown away, as they're used in different types of processing, they do get into the water table. And as they get into the water table, then they get into your plants, they can get into the animals, they can get into other areas, and they tend to bioaccumulate. So even though you're exposed to very small amounts of these materials over time, they build up in your body. And it's not completely understood what all of these things do, but they've been linked to a lot of health problems, different birth defects, decreases in fertility, increased risk of cancers. There are a lot of, I'd say, high-profile stories out there. There was a movie, Dark Waters, that talked about the effect of PFAS. The Philadelphia Phillies at Veterans Stadium, people believe that there's been some problems associated with the turf that was used there over the years. There's a lot of news stories associated with that. We have a lot of links on our offer page and our websites, but these are chemicals that at the time nobody really knew that they were going to cause a problem because it took a number of years to see these effects. They're very prevalent in areas where there are airports, anywhere where there's military. Anywhere where there is a high concentration of industry is sort of these clusters of where you're going to see these things. But PFAS have been found literally almost everywhere. They've been found in Arctic ice. They've been found in the rainwater in the Australian outback. It's estimated to be more than 80% of all the U.S. waters are contaminated with high levels of PFAS. So it's been a challenge. And earlier this year, the EPA announced pending regulation on only 4, maybe it's 5, might be 6. I can't remember the exact number, but there's 4 main ones that people are worried about. But they're beginning to regulate them in drinking water, and that's the first regulation. It's a few compounds out of thousands, so it's just a start. But people are beginning to become aware. Corporations are becoming aware of what they're doing. So there is still a portion that are reacting to these pending regulations. But what we're seeing is the beginning of proactive behavior to try to go in and remove these things before they are forced to, because it's the right thing to do. The challenge is, again, until really recently, there hasn't been a good way on a very large scale to both capture and destroy them at the same time. And that's what we've been able to do. We've been able to find a very cost-effective, efficient way to do that. Our first prototype does not have UV in it. So what we see is so there's been a lot of, we've been asked this a lot, and we've had a lot of commercial customers and even some companies ask us if that's something we can do. So what our material does is it does 2 things. So the surface of our catalytic crystals attracts the PFAS, and it does that by a process called adsorption. So it's adsorption. So it essentially sticks to the surface. So by having a filter without the UV, we do have the opportunity to remove it from water. But what we have there is then we have the same problem that other potential solutions have as well. You have moved the contaminant from one place and put it into another. So to be able to do that on the consumer scale quickly, we could have a system that would not have UV light. And what that would require, that would likely be a subscription type filter where they would use it for a certain amount of time. They would send it back to Invicta Water, and we would handle the destruction in a larger system, and then we would replace that with something else. But we do envision an opportunity to design a filter in such a way that we could maybe have a base where it sits so that we can incorporate UV light in that filtration to do the destruction at the same time. Shorter answer is, yeah, you have to have UV to destroy it, but a filter to remove it could be something that we could get into the marketplace pretty quickly. And then as we progress, we could find a way to shrink down that UV energy to have it where it could fit in a pitcher or something that you drink out of. There's a wide-ranging estimate of how big the markets are. And the way we look at it is municipalities, which would be your government-run drinking water and wastewater plants. That is the industry where we're beginning to really start first. That could be, certainly greater than $100 billion a year. But if you took the average amount per gallon of water that's being spent at some facilities, and you extrapolated that across how many water facilities there are in the U.S., now you're talking closer to 5 or 6, maybe $700 billion that they're going to spend on that. Now, our solution is significantly less expensive. So even if all of those converted to Invicta Water, it wouldn't be that high, but that just shows you that there's a tremendous opportunity from the municipality point of view. And that would be the largest systems that we would possibly do. Those are millions of gallons of water per day. On the industrial scale, it's also pretty far north of 100 billion. And again, it depends on how you break things down, but we look at industrial in a few different ways. One, there are the large manufacturers, semiconductor plants, pharmaceutical plants, other manufacturing, all the way down to food and beverage, and even down to, say, microbreweries. So having that PFAS-free label on a bottle of water or an energy drink or a beer or a beverage or even food, if you talk about hydroponic farming, some other things, we believe there's a lot of value there. The consumer business, from what we see, the U.S. is probably the largest consumer of these personal filters. And that is estimated to be, north of, say, $50 billion a year. And that's before you even go international in some of the larger communities or some of the larger population areas that just haven't gone to using those yet. And then you also have the remediation side of things. So the cleanup, right? And it's hard to estimate what that might be, because I think the value is well beyond the revenue that would bring in. But if you could imagine, if you could put something on the back of a truck that you could drive up to a spill or to a retention pond that has some challenges, and you could pull out the bad water and pump back in the good water, that's something that we would also be pretty focused on. So it's a large market with a bunch of different verticals. The beauty behind what we're doing is our catalytic crystals that we would use in that personal filter for the consumer is exactly the same that we would use at a water treatment plant in a municipality. And really all we need to do is scale the technology. So it is one material science that is using to do the purification across all of these different applications. Yeah, so boron nitride as a material, it has tremendous capabilities. It can do a lot more than just PFAS. And we are doing experiments for other organic molecules, over-the-counter pharmaceuticals that get dumped down the drink. Things like artificial sweeteners, nicotines, a lot of these things that are classified as emerging contaminants that we're not yet really studying or regulating. We've been getting to do work on some of those to get ahead of that. But I think what he's asking is, can we clean really polluted water? There are better ways. There are probably cheaper ways to do that. When you get water out of, say, that leaches out of a landfill, it's called leachate. And if you looked at a glass of that, it's going to look like coffee almost. It's a very muddy brown because it has a lot of different things in there. There are a lot of steps that you can do that you can do on a very large volume that can get rid of a lot of the vast majority of what would be the main pollutants. So if you think about this like an air filter, if you had a HEPA filter, there's usually a pre-filter that filters out the big stuff before the cleaner air goes through that HEPA filter. We're kind of like that HEPA filter. We would be close to the end. But we are actually right now beginning to do some studies on how our material would be impacted by things like the leachate and some of those bigger things. So it can do that, but there's probably better ways to get rid of, say, 90% of the large contaminants before we start doing the catalytic breakdown that our material provides. And the challenge is because if you think about the amount of PFAS in water is pretty small, right? So if you had 100 million gallons of water, you probably have a pint of PFAS. And that pint is equally distributed around that 100 million gallons. So part of the challenge is, how do you combine it to where you get into a smaller volume to where you can then treat it with the crystals? And what we've done is we've piggybacked onto existing technology that does just that. It gives us the opportunity to have a continuous flow of water while we're moving the bad stuff into a smaller area or a smaller volume, so that we can concentrate our treatments in that smaller area, but always have a continuous flow. So we're not doing something like a batch to where you have to spend a lot more energy and then release it. It's a low energy continuous flow. Yeah, so there's actually quite a few. Cost is certainly one of them, and there's a water treatment plant in Wilmington, North Carolina, which is on our coast, that we like to compare to. And they spent it's public knowledge. The information that we are citing is what we've read in public documents. So we don't have information on the exact numbers, but they spent somewhere around $40 million to dig giant holes that they fill with carbon. And by giant holes, multiple Olympic-sized swimming pools. And that carbon needs to be replaced over time, because all it does is, again, it pulls it out of the water, and they still need to dispose of that. $30 to $40 million they spent doing that, and they'll have considerable, multi-million dollar operating expenses every year. We would be a fraction of that cost. But another thing that is just as big of consideration, Wilmington they're lucky in that they have the land to be able to dig that many large holes. So when you start going into higher density areas or some cities or places, say California, they really don't have the ability to have acreage to use for something like this. So we also have a very small footprint, and there's a tremendous amount of value there. It's very low energy, so the operating costs are low. And then the other value that we bring is the time to install is short, right? It should be months instead of a year or two to do some of the things that they're doing now. And then the other thing that we have is we can customize the equipment to the toxic chemical or to the compounds that we're trying to remove. So we have a sort of I would say a generic or a standard system that will go for the PFAS that are being regulated or being proposed to be regulated. But if, say, it's a manufacturer and say, well, we know exactly what our compound is, well, we can tune it to approach that. And the beauty is, well, if a year from now, if they have a new compound, all we need to do is make some other changes to what already exists. So we don't need to replace it or add on, but we can just change the way that we have our interactions with those contaminants. So it really is, it's a suite of advantages, and it's disruptive to the industry. Right. Today, if a municipality water treatment plant wants to have a solution, they typically will engage an engineering firm who will do a study, and then they'll do a plan, and then they'll do the implementation. You're talking probably 12 to 18 months, millions of dollars before you really even get equipment on the ground. We need to know how much water are you pumping, what might be in it, and how much land can we take up. And then we can just chart out, what equipment you need to buy. So it's not only a disruptive technology, but it's a disruptive model. And it really knocks down that cost barrier from people saying, I would love to get rid of the PFAS, but I just can't, spend that much money. Now that goes away. And now we have an opportunity to do it in a cost-effective way as well. The molecule is actually broken down. So it breaks the bonds. It breaks the chain down. So what you end up with is, you get a little bit of CO2 off gas, and again, a very small amount. And then you get ultimately what turns out to be a very small amount of an acid, of a fluoride acid, HF. And you can combine that with, say, like calcium or some other materials, and you create like calcium fluoride, which is kind of like what's in toothpaste. So it breaks it down into very innocuous different molecules. But again, there's a small amount. So it's not like we are creating a greenhouse problem. It's a very limited amount of CO2 in there. So it actually destroys it. So it takes the forever chemicals and it removes them forever, and it breaks them down into simple molecules and things that aren't harmful to us. We want to invent as little as possible, because invention takes a lot of time and it takes a lot of money. So what we want to do is we want to take things and technologies that exist, and we want to innovate on top of them, or we want to change the way they're used. So that's what we've done. There are a lot of other UV technologies for other things in industry and else, but I think this is fantastic. I think this is phenomenal. So what we would do is, for something like this, the difference that we add, when you are flowing water through some of these systems that have UV, you are working on the probability that UV light will interact with the chemical at the right time. With what we're doing, by having our materials, we are creating a surface that we know will have the PFAS or these emerging contaminants on top of that surface. So we can direct that UV light to where it needs to go. And one of the really creative things that we're doing, a partner that we've worked with, that we've had some videos posted by them and we've talked about working with them, is a company called TrueSpin out of Alabama. We are working with them to find a way to blend our material into a matrix, so something that looks almost like an air filter, like a furnace filter, so that now we know a surface that is completely coated with our material. So what that would do is that would give us that target. So now we know where to focus that UV energy. So we're not wasting energy just blasting it out everywhere, but we're targeting in a very specific location. And that gives us the opportunity to be more efficient, more effective, and to also to do it cheaper. So, obviously the material that we use is based on BN Nano's boron nitride nanotubes, or their nanobarbs, and Invicta Water does have exclusive rights to that material in water treatment. So from that perspective, there's a patent there. Now, if you, and there's a picture of this on our offer page, we have 3 stages to what we do. We have the stripping, we have the enrichment, and the destruction. And in the stripping is sort of the big, where we're getting as much of the bad stuff out as quickly as possible. The enriching, we're getting it kind of closer together. And in the destruction phases, when we're actually breaking those bonds. Each one of those areas, we do see an opportunity for IP, patentable, and also trade secrets. And what we're doing right now is we are going through that evaluation of what do we think we should or could patent, and what do we want to maintain as a trade secret. And it's a delicate balance. It's not only, what are you trying to protect, but the cost of patents are quite high. And when you do have patents, you are disclosing publicly what you're doing. And there are a lot of places where people will take advantage of your patents and not necessarily follow them. So, there is an art to that. And I will say that, our team going all the way back, we all hold patents. I have some patents from other technologies. Jason has a number of patents. Mark has quite a few. Our team, the founding team going all the way back, has hundreds of patents in different industries. IP has been ingrained in us since really, we started working. So it's something that we fully understand the value of IP, but we also understand that sometimes a trade secret is worth more than a patent. It's certainly something that we are continuously evaluating. And with the changes in the patent laws, you do have the opportunity to file provisionals at a relatively low cost. So that is something that, we are taking advantage of. But absolutely, IP will be important on really all aspects of what we do. Yeah. So again, we want to kind of break it down into the different areas that we talked about. There's the municipality side of things. And so the municipality would be the largest systems. So when you think about those, again, those are the first pilot that we're going to do. The wastewater plant handles, I think, somewhere 5 to 7 million gallons of water per day. So that gives you the idea of sort of the first full production size, if you want to call it full production. Our pilot will be a percentage of that just to demonstrate that it works. So if you look at a municipality like that, that would be a small, less than 10, but certainly multi-million-dollar type of business. There are a number of municipality plants around the country, but so that would possibly be, a good way to get a lot of high dollar revenue. In the industrial side of things, there's really two opportunities. There's the large users, say the manufacturers, which we would likely see, they would be treated like the municipality. We would sell them equipment, potentially maintain it or help them operate it. But there's also the smaller end of the industrial scale. If you start talking about food and beverages, microbrews, energy drinks, we believe, because of the cost of our equipment is relatively low, that we see a leasing model for those folks. To get them to where you're only adding, say, a fraction of a penny per gallon or a very small amount per gallon, because a lot of times they have much tighter margins. They probably don't want to spend a lot of capital and they don't want to do a lot of maintenance. So we'll lease it to them. So, that's a model that we're working towards right now. And then there's that consumer, the direct to the consumer as well, which would be most likely on the personal filter side of things, a subscription model, but also well water and some of the, the under the sink type applications where we could more easily incorporate UV energy to do the destruction. We could see those as, off the shelf products that you could buy at, some of the big box retailers, home improvement type stores. We run into this a lot. People will say, well, you guys aren't focused. Well, it's the same exact material. It's the same exact technology. We just changed the size of things. Now, the difference there would be that personal filter is different, but the under the sink to the well water, to the energy drink, to the pharmaceutical, to the semiconductor manufacturer, to the municipality is all the same technology, just shrunk down or expanded in size. Yeah, so we are, we don't like to talk publicly about what we're doing until we're confident that we actually can do what we say we can do. So we've been working on this for quite a while, and it's really only, I would say, the last 6 months or so that we've really started telling the world what we're doing. And we can do that because we know that the material science works. We know that we can adsorb the chemicals, and we know that we can destroy them with UV light. So we've done all of the things that we need to do to demonstrate, to produce the data to show that what we have works. What we've begun to do is to scale that up. And, we said we are waiting for really just the dots on the I's and the crosses on the T's to start our first pilot here in North Carolina. And that'll be our first industrial or municipality scale project. So that is something that we're quite excited about. And so we've demonstrated the technology that works. We've been working with the U.S. Navy has also used our material to show that it works as well. So we know that someone else has been able to do it. And then some local universities. We have a professor at a local university just down the street from us, Elon, which is they've been able to demonstrate in their laboratory that it works as well too. So it works. So now what we're doing is we are just going up that chain. So we have that first pilot. Again, we're just waiting to finalize the contracts. And then we have a number of proposals out for industry users. So we're quite excited about that. And then we are also, based on a lot of really a pull from the industry, we've really started working on that personal filter. We thought that we were months and months away, But with partly because of the work that we've done with the company that I mentioned previously, TrueSpin, we've been able to find a better form factor for our material to help develop something like that consumer filter quicker than we thought. So we're preparing for the first pilot. And then after that, there's a number of people that didn't want to be first, but would love to be second. So we're really excited to get that first one going. So the first major milestone will certainly be that first pilot. And while we expect that to be in a municipality, I would not be overly surprised if some of the industry folks that we're talking to leapfrog that and we get that going first. I am cautiously optimistic that we will have, be able to announce our first pilot, the details behind it in the next few weeks. I'm also cautiously optimistic that we will have a system working by the end of the year. So it just depends on, how large that is or how quickly it is. I would like to say that we'll have some other improvements, new prototypes for the pitcher filter, if you want to call it that. I think that would be, important for us. But really what we're focused on right now is the business side of things, getting those first sales, getting those first pilots. And really, as you said it, and I'm probably going to steal the way you said it, nobody wants to be first, but they want to be first second, or the second first, or I said it. So we have a lot of people that are just waiting for that. And I think that will be getting that first pilot out there is really going to open up the floodgates. We're having conversations with folks, and they're trying to understand what the value of that PFAS-free label means to them. In some cases, it's a reactive decision. In some cases, it's proactive. They want to go ahead and be on the forefront of doing the right thing. So obviously, all the homework that we're doing and all the preparation that we're doing, until you actually have something installed and running, you don't know what you don't know yet. So we are trying to anticipate and trying to get an understanding of that. And a lot of that has to do with partnerships and relationships with people that, the OEMs of some equipment. So we're not trying to reinvent or to relearn things that people already know. We're just trying to make sure that we have the team ready to really solve any of those challenges. So that I think is probably easy to imagine. What scares me the most is managing the growth, right? I mean, I think we have, again, it's a disruptive technology, it's a disruptive business model, and there are ample opportunities to put this to use once we prove that it works. And just managing that growth and how do we do it, I think, is going to be the important thing. And again, the beauty behind what we're doing is, with the folks that we know and the relationships that we've built, we have a lot of people that are ready to either join the team fractionally or full time to really help us manage that growth and be successful. It's interesting, the technology, as exciting and as interesting and as difficult as the technology is perceived to be, it's the interpersonal dealing with people that's actually the challenges. And anyone that runs a business probably knows that, right? It doesn't matter how cool your stuff is or how great it is. You got to be able to sell it. You got to be able, it's got to work. You have to have that trust. You have to have that reputation. So what we're doing now is we're trying to grow that side of the business. What we're doing is we're using a technology that can do a gallon per minute all the way up to millions of gallons per day, or a gallon per day to millions of gallons per day. It's bigger pieces of equipment. So I don't ever want to understate the challenge going from the small scale to the large scale, because there's always things that you don't anticipate. But from what we understand, it should be relatively straightforward. Again, we're partnering with other folks in the industry with some of the OEM equipment that we're going to have built and use. And that's what they do every day. So where our technology comes in, it will be on the sort of, I would say, the leading edge before we discharge the water. That we understand quite well. So it's how does that interact with everything else? I believe it will be a challenge, but I believe it is something that we can absolutely overcome. And I don't expect to have too large of a learning curve. Again, the pilot that we are working towards, I would say, is probably on the smaller end of a waste treatment plant. It's not in a huge city, so it's not millions and it's not tens of millions of gallons per day. It's probably on average 3 to 5 with a max of 7. So it's going to give us a good place to start that prototype. Essentially, everything we're doing is off the shelf equipment and off the shelf technology. So it shouldn't be. It's not like we're inventing it. I don't want to say it should be easy, but we're prepared for lots of different scenarios and contingencies. I do expect the wells and the under the sink is probably going to be a little bit more of a challenge because we're shrinking it down to such a small form factor. But I think we've got a good head start on what we're doing there. We've even have a few people that have volunteered to, put something at their home when we want to try things out. So I think the well is probably going to be faster than the under the sink. And then, as one of the questions, was pretty astute in noting that filter, since it doesn't have UV, it's completely different. So that we could make pretty quickly. But again, having something incorporated with UV light is going to take a little bit of time. The beauty is, if we figure out how to do 2 or 3 million gallons a day, there's a huge market that we can address right away. If it takes us a little bit longer to get to the 10 to the 15 to 20 million gallons per day, that still fits into the roadmap, but we don't have to do the biggest first, which gives us, flexibility to not only create products and grow the business, but it gives us time before we, have to do something like that. Before the net capital raise, it was wholly owned. So every single share of Invicta Water was owned and assigned to BNano. Now, since we started the net cap raise, obviously the shareholders now take a little bit away from that whole ownership. When we first started BNano, our vision was to have these other companies that are using the technology but could be self-sustaining on their own. And that was the model that we presented since Jason and I first thought of this on just a sheet of paper. And even with our founding angels, that was, the model that it did. So yes, it was wholly owned. So if you are a shareholder of BNano, you are indirectly a shareholder of Invicta Water, and you will participate in the success of Invicta Water. Our goal is to reward our shareholders at every level. If you are a direct investor into Invicta Water, you are not necessarily a shareholder of BNano unless you have also invested in BNano. So it is two separate entities, but BNano does own the Invicta Water. And we thought that was important for a number of reasons. One, it's completely different. Being a materials company working on, materials that will be turned into other things is different than actually building and installing and maintaining systems for water purification. So it's going to require a completely different skill set as we grow, sell, and, maintain that business. But we also saw the opportunity to have an international marketplace with water, right? There is a U.S. document out of the White House, the global water strategy, and it states clean water for the world. BNano, because of how that IP works and everything else, there are certain places in the world that we don't sell to or participate with. But water, it's easy, right? It's every single person on the planet, and we fundamentally believe that. And it's important enough to where we wanted to make sure that we had an organization that could address all of these different things. So it is wholly owned. Again, our shareholders are always first in mind. I think we did some presentations as BNano on NetCap where we talked about we would have a wholly owned spin out for the water company. I believe it was probably this Fireside Chat for BNano all those years ago. And that's exactly what we did. Are we worried about it? It's something in the back of our minds, but what we believe is the way we've designed the system where it shouldn't happen, right? So when we talk about it, we have the stripping, the enrichment, and the destruction. Our crystals will be physically present in the destruction. And I expect we'll have a more detailed explanation of how things work, a video that we'll put out here shortly to maybe address this a little bit better. But the way that it works, again, the crystals will be in that last piece. And you can put physical filters, very simple physical filters in line, like a HEPA filter, that would potentially capture anything if it did escape. But by the way that the technology works and by having these safeguards in place, we don't expect there to be any escapes. It's something you can test for, instead of just saying it, it's something that we can certainly prove. But that's not something that we're concerned about. From the stripping, you move forward to your waste stream moves forward, and then you have a clean water return. So in the last box, the PFAS destruction is where we will have the crystals, and that water is returned to the previous step, which then goes back. Doesn't describe everything that we're doing, but you have simple technologies, backflow preventers like you have in your yard, and some other things to prevent water from going where you don't want it to go. And with physical filters, you can block those from escaping. It's still private, yeah, it's still private. We're not public. We are, we're engaged in growing that business on a number of different verticals as well. We're still, I would say, in the growth stage. Nothing's off the table. No decisions have been made, but we are still private. It's much more than a business. I guess there's no other way to say it. What we have found is, we're passionate about material science. We're passionate about emerging technologies. We're passionate about disrupting and thinking differently. And when you can combine that passion with finding something that can clean water and truly change lives, it's not hard to wake up every day excited to go to work and to really to put forward in things. Everyone has families with health issues, right? And we're no different. There's been people that we know, that we love, that we care for, that likely because they've been exposed to water over the years has given them health problems. If we can find a way to not have anyone else go through that while at the same time growing a business, helping our shareholders and helping ourselves, but just by doing the right thing, it's hard to find that combination, right? As excited as we are about some of the technology that we've done with this boron nitride nanobarbs in other places, I can't think of anything else that could potentially have the impact as cleaning water would have. Water is a strategic resource, right? They talk about things that are going to run out. You don't have to look far, right? In the news every day, the Colorado River is drying up. There's other places. San Diego is trying to figure out how to get water from the Tijuana River, but it's polluted. All these different things. This is a challenge. The Middle East, how do you get clean water in the middle of the desert? How do you do this? This is just one little piece that can help solve some of those problems. For us, is fantastic. Being a part of that is incredible. Knowing that things that we have been able to create, invent, patent can enable this, it's amazing. It makes, when you are having that conscious side of capitalism, to me, I think that's the perfect innovation, the perfect thing to do. We're doing the right thing and growing a business at the same time.